Howdo. Welcome back to the shop. We're still on the little rotary table project here, and our next victim is this table locking mechanism. Now, this is terrible. it's bad. So you've got a cast iron piece here that your worm gear is cut into, and you've got like a, I don't know, 5mm probably, a metric 1024 bolt. I guess that's 6mm. So you've got a 6mm bolt that screws in here, and even this handle is cheesy. All this is just a little turned handle with a set screw screwed into it. That's how they made this. That's lovely. So that, you run that in, and that just presses here on the worm wheel, or worm gear, and you can see, maybe, you can see where it strikes this table or this cylinder here. It strikes it right about there, and you know, in the course of cutting gears, you're going to put divots all around in this thing, and that's probably going to displace metal into the actual worm gear, and I can't see anything good coming of that. So what I've got in mind here, I took some aluminum, or if you live in a communist country, aluminium, and it's 1-inch thick plate, and what I've done is I bored the outside with a hole saw down about halfway, and I used a 3 5/8, just regular old Lennox hole saw for cutting wood and breaker boxes and transfer switches. I bored about halfway with the 3 5/8 hole saw, and then I switched out to a 2 9/16 hole saw and bored the center out, and then I went back to the 3 5/8 hole saw and bored the outside till I had this cylinder cut out. So the first thing I want to do is turn the OD of this until I've got a really good fit down into here, and then we'll flop around. We'll turn the OD to where that'll flop over the top of this, and then once we get the OD and the ID cut, we'll transfer punch to where this screw is just, I just want a place for this screw to register, or a screw to register into this. Once we get that done, then we will cut along this line right here where the worm eccentric goes in, and we'll lop off about that much material, and you know, break the sharp edges and stuff. But my goal here is, you know, as you press in on this, you know, that'll spread the weight here, or spread the force to where we're impinging on the whole face of this worm wheel. I want to, and at the same time, it should, or it could, I don't know if it will or won't, but it seems reasonable that this will squeeze as we're trying to move this cylinder inside of this cylinder. It should squeeze this down if we've got a big chunk of it cut off here, and it'll kind of bite like that, as well as push on one spot. This is a terrible setup. I don't like it. I would much rather have two clamps that clamp down 180 degrees apart to clamp the table down to keep it from turning, rather than push sideways to keep it from turning, because that's putting all of your force on this boss right here, the central pivot, spigot, boss, tit, whatever. I don't like that, but honestly, we're not talking about 600 pounds of force. We're talking about 20 ounces of force. You know, it's not going to take a whole lot to lock this thing in place against rotation that's coming from my little bitty milling machine. So we'll get set up here in the lathe here directly. So I've been doing what old Dave Richards called free-form machining, and basically it's just making her fit. And I've just got it to where it's just barely going up on there. So I think I'll take about 4 more thousandths off of that OD. I want this thing to be a nice, easy fit, but I don't want it floppy. I just want just a little bit of clearance in there. I mean, it is aluminum after all, and it will try to gall. So we don't want her to gall inside of that iron housing. And we just about cleaned the whole OD up. So I believe that's going to work. Oh, it's a good fit. That's just what I wanted. So I think I'll switch her around and, well, face this face off, and then we'll switch everything around and grab it from the outside. So you can see kind of how what my setup is here. I'm just boring the hole out. Now, I don't like this setup, but it's the best I could come up with. When this starts getting thin, because this will finish at about a little under a 1/4 inch thick wall, I'm hoping I'm not got a hold of it so tight that it's going to distort it. And I'm kind of keeping an eye on how hot everything's getting too, and taking about 40 thousandths passes, trying to keep the heat out of it, and, you know, take your time, keep the heat out of it, because heat is distortion, distortion is heat. Another thing I've got here is I've got my indicator set up. When I hit 100 and about 3 thousandths, I'll be hitting the jaws. So I got to stop at 100 thousandths on this indicator, and hopefully that'll keep me from crashing into the jaws. So we've got about a 5 thousandths slip fit in there, which is just about what I wanted. Again, I'm kind of doing this by feel rather than measurement, because I don't have the proper measuring tools to get accurate measurements on stuff over 3 inches. So, and I don't have no snap gauges big enough. So I'm just kind of doing the best I can with what I got, which is, you know, kind of my life story. So I'll go ahead and get this bar knocked off here and get a little chamfer on here and a little chamfer on here, and flip her back around, and we'll take that ring off the inside and then face this down to its proper height. So I've got all my turning done on this. The surface finish came out very good, for me anyway. And got a great fit in there. Good fit on the table. So what I'm going to do next is just put me a little center mark in here. Now I'm going to go over to the drill press, and I'm just going to touch that just enough to where the end of a bolt just barely reaches in there and stops this from turning. I want the bolt is going to serve as a pin and as a push. So it's going to push and stop this from rotating. So to the drill press we go. So got the ring back in the hole here, and that does pin it in place quite well. And I mean, don't take much at all to lock her down. Yep, believe we've got a winner. Quarter turn on that is the difference between free spinning and locked. So I'm going to go ahead and pull this apart. And I'll transfer this line. I kind of eyeballed with the eccentric inside of there. And I'll transfer this line across and cut it off and knock the corners down on the belt sander, and we'll put her together. So I dug around in my box of collectibles rare and precious, and I found one of my little 3/4 inch square nuts that was drilled for the appropriate size, and I went ahead and tapped him, scrounged around, and found a great big long set screw that came out of something. So there's my new lock bolt. And you can kind of see the action out here on the ends. This is squeezing together as this is pushing in. So I don't know that I'm going to get 3-point contact, but it certainly looks like it could be possible. At any rate, the load, when you put the brakes on, the load is spread out a whole lot better now than what it was. You know, if you'll remember, we were just bearing on one little bitty point, and now we're bearing on much larger surfaces. And the difference, like I said earlier, the difference between free running and locked, and I mean locked, is about a quarter turn. And if my old crippled up hands can lock that 3/4 inch square nut down, or square headed bolt down tight enough to lock that table, we've got a good braking system. So I think the next part of this little project is going to be to make a foot for this to where I can mount it to my lathe. And or maybe we'll work on the crank and the index plates and all that jazz. Anyway, I hope y'all enjoyed. Y'all drive safe. Watch for deer.